Okay, welcome to this video. Let me check if I'm recording. Yeah, I'm recording. My name is Aldy Agustiansyah and my student number is 0619101061. Disclaimer, I make this video unscripted and I have no intention of editing this video. So I might be blubbering in the future, so I'm sorry for that. And I'm sorry for the bad quality of the audio itself. So the purpose of this video is to complete assignment from Professor Vidi. So the assignment is to read 10 papers that are have a correlation in our field. So in my case, it's computer vision. So now I'm going to elaborate what I've read from the 10 papers that I've found. So for the first one, it's going to be a computer vision for animal ecology by Benji Weinstein. So we start with the background and problem statement. Animal ecology struggle with separating animals from the background in the videos and images. This is where computer vision comes in. While background subtraction algorithm exists to address this, they can be fooled by wind, waves, or camera movement. The big problem for ecologists is the difficulty of directly observing animals, especially rare ones. They need a way to automate this process using computers. The goal is to develop computer vision tools that can analyze images, find animals, and learn about their presence, numbers, and behavior without disturbing the environment. This would be faster, cheaper, and allow them to study animals in more places. So for the research question, the research question in the field of animal ecology and computer vision include: 1. How can computer vision algorithm be optimized to accurately detect and identify species in images collected in natural environment? 2. What are the most effective methods for quantifying animal behavior using image-based computer vision techniques? 3. How can high-resolution satellite imagery and computer vision technology be leveraged to monitor wildlife, population, and habitats? Those are the big three. Those are the main one. So for the research purpose, researchers in animal ecology are using computer vision for a variety of purposes. 1. Identifying species more accurately in image and videos from the field. 2. Analyzing animal behavior by looking at the things like color, pattern, and movement. 3. Monitoring wildlife population using high-resolution satellite imagery. 4. Assessing underwater habitats by creating 3D models of organisms. 5. Studying animal behavior in lab using 3D computer vision technology. Those are the research purpose from this paper. Existing method. Animal ecology research leverages various computer vision tools. Image analysis platform like BISCI, 3D reconstruction software like Agisoft and others, pattern matching tools like Nature Pattern Match, animal detection software like Motion Mercat. Species identification tools include Google Cloud API for general image, data management tools like Wildbook to track individual animals and ecological data. So next, the contribution. The contribution from this paper is animal ecology get a big boost from computer vision. This tech automate data collection, finding, counting, identifying animals, improve species detection in image, and even help analyze animal behavior. It also allows researchers to monitor wildlife population better using satellite and help them analyze the massive datasets they collect. Basically, computer vision makes animal ecology research more efficient and insightful. So the result from this paper is sharper species ID, deeper understanding of behavior, better population monitoring, faster data analysis, and technological leap. So those are what I found from the first journal. So we're gonna move on to the second journal, which is how good is my test data? Introducing safety analysis for computer vision. Oliver Zendel, Marcus Mursitz, Martin Hammenberger. Yeah, I think that's correct. Wolfgang Herzner. Sorry for the bad pronunciation. I can't read Germany. Yeah. So the background and problem statement from this paper is validating computer vision (CV), what we call computer vision, system is tricky. The challenge is figuring out what to include in test datasets to make sure the system is strong and avoids unnecessary repetition. The papers discuss using existing risk analysis method HAZOP, FMA, CA, FTA to find weaknesses in computer vision system. They also use control theory to understand how information flows through the system. By figuring out what might go wrong, they can design test datasets that specifically address those weaknesses. This will ultimately lead to creating better computer vision system. Research question: what are the key challenges in validating computer vision system? How can risk analysis method like HAZOP, FMA, CA, and FTA be effectively applied to assess risk-related attribute in computer system? How does control theory model interaction of systems and information flow in the context of computer vision? What is the impact of hazards identified through computer vision HAZOP on the output quality of computer vision algorithm? How can test datasets be optimized to cover known hazards and reduce redundancies in computer vision validation processes? Those are the research questions. We move on to the research purposes. To identify and address the key challenges in validating computer vision. Second is to explore the effective application of risk analysis method like HAZOP, FMA, CA, and FTA in assessing risk-related attribute in computer vision system. Third, to understand how control theory models interaction of system and information flow within the context of CV, computer vision. Fourth, to investigate the impact of hazards identified through CV HAZOP on the output quality of CV algorithm. Fifth, to optimize test datasets to cover known hazards and reduce redundancy in validation process of CV system. Existing method. The existing methods conclude 1. Risk analysis method, 2. Control theory, 3. CV HAZOP implementation, 4. Evaluation technique, 5. Test dataset optimization. Contribution. So these papers contribute to 1. Risk analysis method application, 2. Control theory integration, 3. CV HAZOP implementation, 4. Evaluation insight, 5. Test dataset enhancement. Result. So the result from this paper is identification of 947 meaningful entries by experts in hazard analysis, visualization of hazard entry in table 3 and fig 3, probability value obtained from the Wilcoxon sign rank test for different pairings in table 7, clear differences in difficulty level between parameters such as shape, box, and rank. Those are the main purposes. So now we move on to the third papers. So the third papers will be Survey of Fish Behavior Analysis by Computer Vision by Bingshan Liu, Guang Yao, Fang Feng, Jingwu, Longzhang, and Zhengbo Li. Again, I'm sorry for the bad pronunciation, and I can't read Chinese. So for the background problem from this journal and the problem statement is the problem statement addressed in the papers is the difficulty in accurately assessing fish behaviors and psychology due to limitation in traditional observation methods. There is a need for advanced technique such as computer vision technology to provide non-destructive, rapid, economic, consistent, and objective tools for studying fish behavior. The challenge is to develop effective evaluation technique based on image analysis and processing to better understand fish behavior in various aquatic environments, from hatcheries to harvest. Research question: how can computer vision technology enhance the study of fish behavior, stress responses, and feeding habits? What are the benefits of using underwater video technique to observe fish schooling, cohabitation, and feeding behavior? How can intelligent underwater monitoring system and advanced algorithm contribute to accurate fish behavior analysis? Those are the big three. Research purposes. One is to explore the application of computer vision technology in studying fish behavior, stress responses, and feeding habits. Two, to investigate the benefits of underwater video technique in observing fish schooling, cohabitation, and feeding behavior. Three, to assess the role of intelligent underwater monitoring system and advanced algorithm in enhancing fish behavior analysis. Those are the big three. So the existing method for this research is going to be: 1. Underwater cameras. 2. Sonars. 3. Image analysis. 4. Fish psychology. 5. Fishing gear. Contribution. The contribution this paper has brought us is: 1. Non-stop fishing monitoring. 2. Sharper observation. 3. Fishy fingerprints. 4. Location. Analyzing research location reveals interesting pattern about the fish behavior, often linked to area with lots of food. 5. Time-saving tools. Results. So the result from this research is testing escape routes, fish on camera, fish sense, cooperation counts, tech evolution. So that's it from this paper. Great paper, by the way. So we move on to the next paper. For the next paper is computer vision research at the University of Massachusetts. Dance and Progress, Edward M. Reisman and Alan R. Hansen. I'm pretty confident about that though. So for the background and problem statement, these papers explores ways to improve computer vision for tasks like recognizing objects, analyzing motion, and helping robots navigate the challenge include dealing within both 2D image and real-world 3D world they represent, recreating smooth surface from 2D outline, understanding complex scene by breaking them down into parts. The researchers propose using knowledge-based approaches, analyzing motion to understand objects, and combining different vision techniques for robots. Their goal is to make computer vision systems faster, more accurate, and better for AI and robotics in general. Research question. So for the big three research question is going to be 1. How can visual processing capabilities be enhanced to tasks such as object recognition, motion analysis, and mobile robot navigation? 2. What are the challenges associated with dealing with two-dimensional and three-dimensional information in visual processing system? 3. How can smooth surface be effectively reconstructed from profile to desired shape information? Those are the big three. Research purpose. 1. Enhance visual processing capabilities for tasks like object recognition, motion analysis, and mobile robot navigation. 2. Address challenges related to two-dimensional and three-dimensional information processing in visual system. 3. Improve the recognition of smooth surface from profile to extract shape information accurately. Those are the big three. Existing method. So for the existing method from these papers is 1. Low-level algorithm. 2. Region segmentation. 3. Associative access to tokens. 4. Object schema strategies. 5. Perpetual organization. 6. Geometric structure extraction. 7. Three-dimensional geometric models. 8. Mobile robot navigation. So the contribution from this paper is 1. Large-scale integration. 2. Knowledge-based system. 3. Real data analysis. 4. Vision system development. 5. Research trust. 6. Dynamic interpretation system. 7. Real-time robot navigation. 8. Dynamic visual perception. So from all of those, come to the result. The results from this paper is enhance visual processing, improve visual processing capabilities for tasks such as object recognition and motion analysis. 2. Efficient scene interpretation. 3. Accurate object recognition. 4. Effective mobile robot navigation. 5. Dynamic visual perception. 6. Real-time performance. 7. Hierarchical planning. 8. Geometric structure extraction. So that's it from this paper. We move on to the next one. So the next papers is going to be a computer vision based whiteboard capture system by Richard Yi Da-Su, Center for Research in Complex System, Charles Sturt University. This one is going to be the wrong one, so bear with me. Background and problem statement. The system addresses the challenge of continuous whiteboard information captured during presentation, detection of unoccluded quadrilaterals and update regions on the whiteboards is crucial. Room lighting, camera noises, and shadow from moving person pose challenges. System aims to improve robustness by using background modeling and updating methods. Calibration between static and PTZ cameras is necessary due to differences in extrinsic parameters. Detection of whiteboard's corners and tracking quadrilateral corners without human intervention is essential for accurate capture. The problem statement involves effectively capturing continuous whiteboard information during presentation. Is the essential to detect unoccluded quadrilateral sorry my English quadrilateral I'm sorry and updated regions on the whiteboards accurately despite challenges such as room lighting, cameras noises, and shadows. To enhance robustness, background modeling and updating methods are utilized. Calibration between static and PTZ camera is required for precise whiteboard view alignment. Automated detection of whiteboard corners and tracking quadrilateral corners without human intervention is crucial for successful capture. Research question 1. How can continuous whiteboard information be effectively captured during presentation? 2. What methods can accurately detect unoccluded quadrilateral and updated region on the whiteboard? 3. How can the system addresses challenges like room lighting, camera noises, and shadow from robust detection? Those are the big three from this main purposes. Research purposes. 1 is to develop a system for continuous and effective capture of whiteboard's information during presentation. 2. Implement method to accurately detect unoccluded quadrilateral and updated regions on the whiteboards. 3. Address challenges like room lighting, camera noises, and shadow to ensure robust detection. Those are the answer from the research question. Existing method. So the existing method from this research is 1. Electronic whiteboards. 2. Video recording. 3. Image processing and computer vision. 4. Occasional snapshot. 5. System proposed in. 6. Background subtraction. 7. Camera calibration. 8. Mechanical morphology. So the contribution this paper has brought us to is 1. System design. 2. Continuous capture. 3. Computer vision technique. 4. Image processing method. 5. Enhanced capture quality. 6. Automation. 7. Robustness. 8. Future direction. The results from this paper from this research is whiteboard image enhancement, quadrilateral detection, updated quadrilateral, real-time image comparison, limitation, future works. Those are the results from this paper. So for the next paper is going to be computer vision in the fish industry. From my research is going to be more aquatic because it is interesting for me to kind of observe the aquatic wildlife. So a lot of papers that I've proposed research is going to be fishery. Yeah, and this one is the fishery one too. So computer vision in the fish industry by G.R. Mathisen, E. Misimi S.O., Ostovic, and I.G. Aursan, Department of Processing Technology, Scientific Fisheries and Aquaculture, Norwegia. Then again, I'm sorry for the bad pronunciation because I can speak Norwegian. Background problem statement. The development of an automated solution for pre-rigor removal of pin bones from Atlantic salmon fillets was motivated by the need to avoid the traditional method of waiting for fillets to tenderize, which reduces freshness and shelf life. This led to creation of a computer vision system that can accurately estimate the position of pin bones, enabling efficient bone removal before rigor mortis sets in. The problem addresses is the need for automated solution to effectively remove pin bones from Atlantic salmon fillet before rigor mortis sets in. Traditional method of waiting for fillet to tenderize reduce freshness and shelf life, highlighting the importance of developing a computer vision system that can accurately locate and facilitate the removal of pin bones in timely manners. Research question. How can computer vision technology be effectively utilized to automate the removal of pin bones from Atlantic salmon fillets before rigor mortis? What are the key challenges in developing a computer vision system for accurate estimation and removal of pin bones in fish processing? How does the implementation of automated pin bones removal impact the freshness and shelf life of Atlantic salmon fillets compared to traditional manual method? Those are the three main purposes. Research purposes. 1 is to develop a computer vision system that can accurately locate and automate the removal of pin bones from Atlantic salmon fillet before rigor mortis, of course, improving efficiency in fish processing. 2, to identify and address the key challenges associated with implementing computer vision technology for precise estimation and removal of pin bones in fish processing operation. 3, to evaluate the impact of automated pin bone removal on freshness and shelf life of Atlantic salmon fillets, comparing it to traditional manual methods. Those are the three main research purposes. Existing method. Existing method for pin bones removal in fish processing include traditional manual technique, which invokes skilled labor manually locating and removing pin bones from fillet. However, these methods are time-consuming and can lead to decrease freshness and shelf life due to the delay in processing. To address these challenges, automated solutions using computer vision technology have been developed. This system utilizes imaging technique to accurately detect and locate pin bones in fish fillet, enabling automated removal before rigor mortis sets in. This approach improves efficiency, reduces processing time, and enhances product quality by maintaining freshness and extending shelf life. Research has also focused on the integration of multisensory approaches, such as combining imaging with other sensing technologies to enhance the accuracy and reliability of pin bones detection and removal process. These advancements aim to optimize the automation of pin bone removal in fishing processing, leading to improved overall efficiency and quality control. The contribution this paper has brought us to is 1. Development of an automated solution using computer vision technology. 2. Identification and addressing of key challenges implementing computer system for precise estimation and removal of a pin bone in fish processing operation. 3. Evaluation of the impact of automation pin bone removal on the freshness and shelf life Atlantic salmon fillet. 4. Exploration and potential benefits of integrating computer vision technology in fish processing operation. 5. Optimization of the accuracy and reliability of computer vision system for detecting and removing pinbones in Atlantic salmon fillet. Result. The result from this paper, from this research is high sensitivity in detecting Mycobacterium tuberculosis bacteria and other biological solutions. Enhanced performance due to the synergetic effect of the combination of metals in the hybrid structure. Improved detection capabilities and linearity in wide range of biological samples. The CAF2 substrate contribute to sensitivity enhancements and regular error elimination during setup. Numerical stimulation and FAM analysis confirm the effectiveness of the biosensor in detecting TB cells. Overall, the biosensor demonstrates promising result in biosensing application, showcasing its potential for accurate and reliable detection of biological samples. That's it from this paper. We move on to the next one. Grain quality evaluation by computer vision, T.S. Jayas and C.B. Singh, University of Manitoba, Canada. Background and problem statement. The document talks about using fancy cameras, machine vision system, to improve how we check grain quality in food and drinks. Right now, people manually inspect grains, which is slow, error-prone, and not very precise. This new system uses different camera technologies, color, heat, X-ray, to automatically inspect grains. The challenge is to build a system that can analyze each grain quickly and accurately, sort the good from the bad, and find any problem like bugs or dirt. If successful, this will be revolutionize how we monitor grain quality and make sure our food is safe. Research question. So, again with this paper, there are going to be three main research purposes. Is one, how can machine vision system with different imaging technique improve grain quality evaluation in the food and beverage industry? 2. What are the challenges in developing real-time system for automated grain inspection and classification? 3. How can individual kernel feeders be extracted and used to be for objective classification of grains? Research purposes, the main three. To investigate the effectiveness of machine vision system with various imaging technique in enhancing grain quality evaluation processes. 2. To explore the challenge and opportunities in developing real-time system for automated grain inspection and classification. 3. To examine the method for extracting individual kernel featured and utilizing them for objective classification of grains. Existing method. Majumdar and Jayas developed image processing algorithm for classification of cereal grain using morphology, color, and texture models. Chalandrai Jayas and White utilize thermal imaging for detection of fungal infection in stored wheat. Kodari, Paiwal, and Jayas employed wavelet morphological color and textural features for classifying cereal grain. Manikavaskat, once again, I'm sorry, I can't read Indian. Jayas and White use thermal imaging to detect infestation by cryotolestus, ferruginous inside wheat kernels. Navankar Singh, Jayas and Wyatt, 2009, assessed self X-ray imaging for detecting fungal infection in wheat. NG, Walkel, Paliwal, and Jayas identifying wheat classes using wavelength features from near infrared hyperspectral images. Singh, Jayas, Paliwal, and White focuses on fungal detection in wheat using near-infrared hyperspectral imaging. Singh, Jayas, Paliwal, and White detected insect damage wheat kernel using near-infrared hyperspectral imaging. Contribution from this paper. This paper is a bit complicated. Overall improvement. Goodbye manual inspection. Objectivity is key by analyzing individual grain. Advanced cameras, big benefits, color, heat, X-ray, and other advances imaging technologies. Safety first. The research considered safety and regulation when using X-ray imaging in grain facility. Thermal imaging for safety. Grain industry upgrade. Overcoming challenges. Algorithms are being developed to address challenges like separating grains that are touching, allowing for more accurate analysis and classification. Result: super accurate classification. X-ray sees all X-ray technology can spot hidden pests like insect larvae inside grains with over 99% accuracy. Thermal imaging detects infestation. X-ray sorting on the fly. Always room for improvement. Researchers are working on real-time sorting, separating touching grain, and improving algorithm for even faster and more accurate grain analysis, which means this paper is still continuing because there are always room for improvement. And I have no idea if someone came up with the improvement idea. I haven't researched it yet. So we move on to the next paper. It's going to be computer vision based date fruit grading system, design and implementation, Yosef Al-Ohali. Sorry. Background problem statement. The background problem addresses in the papers is the need for an automated system to grade and sorting dates based on quality factors like color, size, and defect. Traditional methods of fruit grading are manual and time-consuming, leading to inconsistency and inefficiency. By developing a computer system using image processing and pattern recognition technique, the aim is to create a more accurate and efficient way to classify dates in different quality grades. The problem statement addresses in the papers is the labor-intensive and time-consuming process of manually grading and sorting dates, which lead to delays and inefficiency in post-harvest operation for the date growers. The aim is to design and implement a computer vision-based system that can automate and grading and sorting process, ensuring consistency, uniformity, and efficiency in handling the large variety of date fruits produced in Saudi Arabia. Research question. Those are three main research questions. One is, how can computer vision system be designed to automate the grading and sorting of dates based on quality factors? Two, What are the key quality attributes and factors that can be used to classify dates into different quality grades? 3. How can effective how effective are image processing and pattern recognition technique in accurately grading and sorting agricultural produce like dates? Those are the main three from this paper. Research purpose: 1. To design a computer mediated date fruit quality assessment and sorting system. 2. To investigate the requirement for developing an efficient date sorting system. 3. To test the effectiveness of the developed technique on real-time data. Existing method. Traditional manual method for grading and sorting dates are labor intensive and time consuming. Computer vision systems have been developed for grading other agricultural produce like fruits, vegetables, and grains. So we just have to specifically do it for dates. Non-destructive approaches using spectroscopic and hyperspectral imaging have been utilized for internal quality analysis of fruits. Techniques like histogram analysis, neural network classification like multi-layer perceptron (MLP), external quality factors like color, size, and defect are commonly used for visual inspection and grading of fruits. Advancement in image processing and pattern recognition fields have enabled the automation of fruit grading processes. Contribution: 1. Development of computer vision based date fruit grading and sorting system. 2. Implementation of image processing and pattern recognition technique for the automated fruit classification. 3. Introduction of a prototype date fruit grader sorter for practical application. 4. Evaluating of system performance through experimental results and confusion tables. 5. Contribution to the advancement of non-destructive quality evaluation method for fruits. 6. Exploration of emerging technologies for efficient and accurate fruit grading processes. 7. Enhancement of post-harvest operation in the agricultural industry through automation and technology integration. Result: experimental results show that Model 2 achieved a maximum accuracy of 80% in classifying grade 2 fruits. 80% is kinda big, but we want 90 or higher. Model 2 within fewer input features generally yielded better result compared to the Model 1. Misclassification were observed due to variation in shape, size, color, defect, and limited visibility of features. The system was trained off 1200 sample and tested on 660 samples, which confusion table provide for analysis. Challenges were identified in detecting flabbiness and defects solely based on color and shape features. Further investigation were planned to improve the system performance and addresses misclassification issue. That's it for this paper. We move on to the next one. Learning as a machine. If the previous papers we talk about computer vision a lot. Now we're going to talk about something related to computer vision, which is machine learning. So for this paper, it's going to be learning as machine, crossover between human and machine. Mirel Hildebrand Law, Science, Technology, and Society Studies, Faculty of Law and Criminology, Frege University, Brazil. Background and problem statement. These papers wrestled with the ethical issue of using learning analytical (LA) in schools. LA tracks student data to supposedly improve learning, but there are concerns. Students don't know they are being profiled, which raises privacy and fairness issues. LA might label students unfairly, and it's hard for them to argue against the label because LA results are presented as objective facts. The document calls for stronger data protection, clear communication about student profiling, and ethical guidelines to make sure LA is used in a way that respects students' rights and freedoms. Research question. There are three main research questions. How do LA scoring practice impact the agency vulnerability of individual human learners? What are the differences between behavior and action in context of LA? How does the preemption of intent influence the use of LA in educational settings? Research purposes. Investigate how LA scoring practices affect the agency and vulnerability of individual human learners. Explore the difference between behavior and action in context of LA. Examine the implication of the preemption of intent on the use of LA in educational settings. Existing method. Moll, Kismihawk, and Sculter found out about the method known for excellence methodological reflection. While Princelow and Slade investigate how LA scoring practice affect the agency and vulnerability of individual human learning. Fender found out that explored the differences between behavior and action. Buxtey discussed the preemption of intent in relation to LA. MIT OpenPDS, Max Planck, Air Clock, and PAP frameworks and tools for data protection and pseudonymization. In compliance with data protection laws. Dreller and Dressler found out that discussed machine learning technique for learning analytics. Contribution, ethical reflection, legal consideration, data protection, methodological insight, and educational implication. Result. The paper does not explicitly provide specific result or finding in traditional sense. Instead, it offers a critical, analytical, and discussion of the ethical implication, legal consideration, and methodological reflection related to the implementation of learning analytic LA in educational settings. The document highlights the importance of protecting individual learners' rights, autonomy, and privacy in the context of LA. Key points discussed include the impact of LA scoring practice on learners, the difference between behavior and action in LA, and and pre-learners, and preemption of intent educational settings, and the integration of data protection measures in LA architecture. The document also emphasizes the need for ethical and transparent practice in using LA to ensure fair treatment and non-discrimination of students. While the document does not present specific empirical result, it offers valuable insight and consideration for researchers, educators, and policymaker regarding the responsible and ethical use of LA in education. We move on to the next paper. This paper is going to be the last one. So the last one, we're going back to computer vision again. After we discuss about ethical kind of sense from privacy and such, we're gonna back to computer vision again. Computer vision for micro air vehicle: Roland Brockers, Martin Hammenberger, Yoshi Kuwata, Larry Mattis, and Stephen Weiss. Background and problem statement. The background problem addressed in the papers is the challenge of autonomous navigation for micro air vehicle (MAVs) in complex environments. Traditional 3D grid representation are computationally intensive, and fast vehicle dynamics require a sophisticated planning approach. To overcome this issue, the system introduced image-based world representation and plans trajectories over closed-loop vehicle dynamics. The goal is to enable MAVs to navigate autonomously in cluttered environmental with agility and efficiency. The problem statement addresses in the papers is the need for efficient and agile autonomous navigation for micro air vehicle (MAVs) in complex environment. Computerization limitation hinder the processing of large 3D grid representation, and the fast dynamic of MAV required a sophisticated planning approach. To tackle these challenges, the system introduced image-based world representation and plans trajectories over closed-loop vehicle dynamic. The objective is to enable MAV to navigate autonomously in cluttered environment while ensuring fast and efficient decision making. So this one is about cars. Research question. As always, there are three main research questions. 1. How can image-based world representation improve autonomous navigation for micro air vehicle (MAVs? 2. What planning approach is suitable for addressing the vast dynamic of MAVs in cluttered environment? 3. How can closed-loop vehicle dynamic be utilized for trajectory planning in autonomous navigation system? Research purposes. To investigate the effectiveness of image-based world representation is enhancing autonomous navigation for micro air vehicle or MAVs. To explore planning approaches that can address the fast dynamic of MAV in cluttered environment. To evaluate the utilization of closed-loop vehicle dynamic for trajectory planning in autonomous navigational system. Existing method. So there are a lot of existing methods on this one. Loosely coupled extend Kalman filter (AKF). Prior work on autonomous landing of unmanned aerial vehicle focus on landing on terrain. I'm sorry, I messed that up. Rather than elevated perches. Approaches for autonomous landing often employ monocular and binocular stereo camera system for terrain mapping and analysis. I'm sorry again. Two main categories of approaches are map-based and map-free for visual odometry and navigation. Keyframe-based visual odometry solutions have been proposed for robust and real-time performance in large environments. Dense monocular 3D reconstruction and visual surface analysis are key components of autonomous landing algorithm. Various methods use point, features, homographies, and structure from motion for terrain analysis and landing site detection. Recent advancements in dense monocular 3D reconstruction involve Bayesian and variation estimation models using powerful processing hardware like GPU. Algorithms are designed to find that landing platform in 3D models, not limited to dominant planes, with a focus on efficiency and constant processing time. Contribution 1. Image-based world representation. 2. Closed-loop vehicle dynamic. 3. Efficient decision-making. 4. Autonomous landing algorithm. 5. On-board resource utilization. Result: successfully detection of valid landing location on elevated surface with a success rate of 90%, which is what we want. False positive rates below 0.05% in false negative rates influenced by the quality of input data. So then again, that's great. Introducing of threshold to maximize safety, such as disabling pixel near disparity edges and using percentage threshold for safety. Evaluation of landing site detection in indoor and outdoor experiment achieves successful identification of valid landing targets over 90%. Again, this is great. Utilization of image sequence and pose data for offline analysis, showcasing the effectiveness of the proposed autonomous landing system. Implementation of robust algorithm for detecting safe landing zones and avoiding unsafe or insufficient landing areas. Efficient trajectory planning using closed-loop vehicle dynamic and image-based world representation for agile and accurate navigation. So this paper is about automation of landing MAV or micro air vehicle, or shall we call drones. So that's it for that concludes my research on computer vision. Then again, this recording is happened to be unscripted, and I'm sorry for the low quality of voice of microphone, and I'm sorry for the mispronunciation because I'm still a learner after all. So thank you for stepping by. That's it from me. Have a good time.